All right, so now let's check out what's going on here. It says draw a circle O. So I'm drawing a circle, I'm putting the center in there, I'm naming that O. Draw a tangent to circle O. So a tangent is a line segment that starts on the outside of the circle. You can start it wherever you want, and it's just going to intersect the circle once. That's kind of bad. Sometimes you got to redraw. This is why we do math in pencil. I only want it to really touch once. Maybe I'll start here. Oh, that's nice. So draw a tangent to circle O. Label the point of tangency point P. So where this hits the circle, I'm going to call that point P. Your line segment can continue if you want, doesn't matter. Now it says draw radius OP, line segment OP. So if I connect from point O to point P, there's my line segment. And then here it says, what can you say about the radius and the tangent? I'm hoping you could have made your own conclusion. If you look at the angle here with the radius and the tangent, what do you think is happening right there? And I'm hoping you came up with the fact that those are perpendicular. So if you scroll down in the notes, this is a theorem. So the theorem says, a line tangent to a circle is perpendicular to the radius at the point of tangency. So here was our tangent line, here's our radius. These are perpendicular, and there it makes a right angle. You can shorten it by saying the tangent is perpendicular to the radius at that point. If we put this in conditional form, which we're going to need to when we do proofs later in the unit, we're going to write that if tangent to radius, then perpendicular. So this is the actual conditional statement. If tangent to radius, then perpendicular. And again, we're going to use that later in proofs. What you guys know, when you get perpendicular lines, you're going to get right angles. And again, later, we want to prove triangles are congruent. So this is a way, if we get right angles in two different triangles, we can get that they are congruent. All right, so a new theorem. Keep adding that to your list of things to memorize. We're going to use them all later. And we're going to use them now. So another thing you have to train your brain for is if you have a tangent and a radius, you automatically get a 90-degree angle there. They're not going to tell you that, they're just going to tell you you have a tangent. So you need to look for tangent and radii. It also works with a diameter too. If this was a diameter and a tangent still gives you that right angle. All right, next we are going to learn more angle formulas. Too high. Let me make that a little lower. Okay. So, let's check this out. The measure of an angle formed by a tangent and a chord. So that's a lot of information right there. Let's just stop and look at this picture. If I have a tangent, here's a tangent, it's touching the circle once, it's on the outside of the circle, and a chord is a line segment inside the circle, both endpoints are on the circle. That makes an angle, where the two red lines came together makes this angle. It turns out this angle is half of its intercepted arc. So that red angle hits the circle at arc BDC. So that rule should sound familiar. It acts just like an inscribed angle. An inscribed angle, the vertex is on the circle and it's half of its intercepted arc. That's the exact same thing happening here. So here's the rule, the measure of angle C equals half of the measure of arc BDC. Here's another picture of what it might look like with a major arc. This one was a minor arc. So again, here's your tangent, here's your chord. If you want to draw these a little bit longer, it might be easier for your brain to see its intercepted arc. In between those two red rays is where your arc is. So again, arc BDC is associated with this angle. This angle is going to be half of its arc. The arc will be twice as much as the angle, just like an inscribed angle. So that's another thing you got to train your brains to look for. Look for tangents and chords because you can get this angle measurement. All right, we're going to practice that on the next page. So if we flip to the next page, we have this example. So in the diagram at the right, ray KJ, so here's ray KJ is tangent to the circle at point J. Tangent, so that's important. We might be able to get some measurements out of that. We have to find the value of x, which is kind of weird. It's this angle right here. And we have to find the value of angle y. And the only thing we're given is 35. So this is a little confusing. You have to give your brains time to process what you're looking at. I'm noticing a diameter. From that, you could find all of this. I'm noticing 35 degrees. I'm noticing that's an inscribed angle. Your brain needs time to process all this. From this 35, it goes out to my circle and intercepts arc JL. So right now, I can figure out the measure of arc JL is going to be twice as much as 35. So that's going to be 72 degrees. This purple arc is 72 degrees. But how can that help us maybe find angle X? Remember, we were told this is a tangent, and I'm noticing here's a chord. And this angle, which is marked angle X, comes from the tangent in the chord, and that purple arc is its intercepted arc. So angle X now is going to be half of its arc. So X is going to turn out to be 36 degrees. Now we might need that. It's kind of hard to squeeze this in the picture. We might need to use that later to help find something else. All right, we still need to find angle Y. So something I noticed back in the beginning, here is a diameter, and so there's 180 degrees here. That means this angle, I'm going to color over in purple, right here is an inscribed angle. This is also 180 degrees. This is inscribed, which makes that 90 degrees. We learned in the last set of notes, if you have an inscribed angle to a semicircle, it's a right angle. One more thing you got to train your brain to look for in the circles units is look for triangles. Don't forget about our old-fashioned triangle right here. If you have two angles out of a triangle, you could always find the third angle. So 35 plus 90, we have 125 degrees, and then in a triangle, all the angles add up to 180 degrees. So that missing angle is, if I subtract correctly, is 55 degrees. So angle Y is 55 degrees. So here's my two answers. Angle Y is 55 degrees, and angle X was 36 degrees. So these problems are quite involved. You may have thought about this and even came up with these two answers doing it some other method. So that often happens in this unit too. So it's tricky. Everything you need is in the picture. You just have to decipher it and see what you can get from that 35. A lot of things to be aware of. So look for triangles, look for diameters, look for tangents, look for inscribed angles. Those are all really important. All right, we have a new theorem now to talk about. All right, so if you scroll down, it's already in a box for us. All right, in a circle, if chords are parallel, so think about that for a minute. If you have parallel chords, they're always the same distance away from each other. This should make sense that they intercept congruent arcs. So in this picture, I'm given the line segment AB is parallel to line segment DC. We could even mark it with our parallel symbol. That means, you know, think about this. I'm going to make these longer. This line segment is cutting the circle into pieces. This line segment's cutting the circle into pieces. If these two are always the same width apart from each other, it makes congruent arcs. And just like when we used to mark congruent segments, you can mark congruent arcs with the tick mark. So that's our conclusion. Arc AC is congruent to arc BD. So you might be saying, why do we need to know this? Let's try it right here. So we have an example. We are given line segment AB is parallel to line segment CD, and we have to find the measure of arc BD. This is what we're looking for. So if you have parallel lines, are you guys seeing a Z? You should. Alternate interior angles. If this is 20 degrees, this is its alternate interior angle. Now I'm hoping you notice something. This angle is an inscribed angle, so now you can figure out that arc. It's going to be twice as much as the inscribed angle, so it's 40 degrees. Coincidentally, this is also an inscribed angle. That one's also 40 degrees. So that's kind of proof of what the theorem's telling you. So look for a Z. Don't forget, you know, if you have parallel lines, look for the Z. You're going to have your alternate interior angles. So everything that we've learned this year can come back to play in a circle problem. Every theorem, just it pulls everything together. All right. We're going to talk about more angles. There's kind of a lot in these notes. You got to take time to process it all. All right, so we really have two formulas so far about angles. A central angle equals its arc, and inscribed angles half its arc. There's two more different angle formulas, so here's one of them. If you notice, we have two chords, and they intersect. It makes an X. You guys should recognize, oh, there's vertical angles in this picture. You're 100% correct. If that's labeled angle 1, that one's also angle 1. There's vertical angles. But these vertical angles make two arcs, and there's a relationship between these arc measures and the measure of that angle. And here's how it goes. The measure of an angle, either one, formed inside a circle by two intersecting chords is equal to half the sum of its intersected arcs. So you have arc AC, you have arc BD. So what I'm telling you is if that's 80 and this is 20, if you know the arc measures, you can figure out that angle measure. You would just take 80 plus 20 and you end up dividing that by 2. So it would be 100 divided by 2, which would be 50. Each of these would be 50 degrees. So a new formula for you to remember. For this one, you look for an X inside the circle. You add the two arcs and divide by 2. So the way I kind of remember this, these angles are inside the circle. I'm inside my circle of friends. I've been added into the group. You're inside your circle of friends. You've been added in. So think of adding, because there's a formula later. Same thing, but subtracting. So if you're inside your circle of friends, you've been added into the group. So pretty easy. And again, if your brain's a little confused, extend these chords out, and the arcs are between those. The arc is between those two chords. So it's not that hard. It all comes down to just recognizing it. There's two examples. I'm going to have you guys try example 1 on your own. You can either stop the video and do it now, or you can actually do that in class. Remember, all the answers to my notes are on my webpage, so if you want to do it now and double check, you can. Or you can save that and do that in your groups in class. It's up to you. I'm going to do number 2 with you right now, just so you get use of this formula. All right, so check out 2. If the measure of arc BD is 75, so find arc BD. Arc measurements go on the outside, and the measure of angle DEB is this angle right there. That's 60. Can you find the measure of arc AC? So I don't know what that is. I'm going to label that X. All right, so I got to give my brain time to process. I am seeing inside this picture is an X. I have two chords intersecting. My angle's inside the circle, so the formula I'm using is I add up the two arcs, divide it by 2, and that's going to equal my angle measurement. So to solve, I have to multiply both sides by 2, to undo dividing by 2, and then subtract. So X ends up equaling 45. And it's an arc measurement, so I can put degrees. So the measure of arc AC is 45 degrees, and that's all the question wanted. So again, it's just more to look for. I know what you're asking. What if the angle's outside the circle? That's what we're going to look at next. So another formula, the fourth formula about how to find angle measures is right here. It's going off the screen a smidge. That's all right. Let me fix this, make it all nice. Oh, that's perfect. All right, I have 3 pictures. They're all actually saying the same thing. The measure of an angle formed outside a circle by 2 intersecting secants. All right, so I just said a lot. So let's check this out. Line segment AB is a secant. It starts outside the circle and it touches the circle twice. Same thing with line segment CB. So the angle formed right here by those 2 intersecting secants is now equal to half the difference of its intercepted arcs. So remember, think of the flashlight. The flashlight's going to hit the circle here. It's going to hit the circle here. So you're going to take the bigger arc, the measure of arc AC, subtract the smaller one, the measure of arc DE, and then divide that by 2. It's the same as multiplying by half. And that's how you get that angle. It works if you have one tangent and a secant. The flashlight's still hitting the circle here. Here's an arc from A to D, and then the other arc is arc AC. So bigger arc minus smaller arc divided by 2. It works with 2 tangents. It's the same formula. 2 tangents, this angle, you would take the bigger arc, arc ADC, the major arc, subtract the minor arc, and divide it by 2. And that's how you figure out this angle. So remember in the other formula, the angle was inside the circle. If you're inside the circle, you've been added to your circle of friends. This angle's outside the circle. You've been subtracted away from your group of friends. That's how it helps me to remember which one do you add, which one do you subtract. All right, so that's the formulas. Then we just have a bunch of examples. I'm going to do example 1 with you, and then you are on your own. You can finish the notes on your own, check your answers on my webpage, or we can work on them together in class. If you want to try them on your own, that's awesome. So I'll do number 1. If the measure of arc ST, so I'm going to stop, find arc ST is 150 degrees. There we go. And the measure of arc QR, this one is 70. Can we find the measure of angle P? I'm going to label that X. Your brain's got to process. There's 4 kinds of angles. Central angles, inscribed angles, angles that come from an X inside the circle, or angle that's outside the circle. Once you've identified what kind, hopefully your brain will say, oh, I know, this is the formula where I have to take the bigger arc minus the smaller arc and divide it by 2 to get my angle measure. So 150 minus 70 gives you your 80. 80 divided by 2 is 40. So our missing angle is now 40 degrees. All right, so there's 3 more problems in the notes plus that other question I wanted you to do. So try them and we'll talk about them in class. Thanks for watching. Have a good day. Bye.